Good morning, everyone. This is Toulouse, a famous church in Toulouse, in a street very well known in the center of Toulouse. And I'm happy to present you with this topic, which is about the influence of dehydration. Let's forget about chronic. This was a title Jane gave to me, on cognitive function better than cognitive decline. If you read just behind me, it talks about hydration and performance. And obviously there are and there will be many claims about the fact that hydrating someone may be something good to do on him, on her, for her cognitive function. We will see some claims like that. And when I first reviewed the subject in 2005, I was convinced that there was a straightforward relationship between hydration and cognition. This is what I wrote in this paper published in Nutrition Review. Although I said at this time that we were very far away from an optimal definition of water requirements and of optimal hydration, and there were many reasons for that. The first logics in this relationship between cognition and hydration is that everybody that deals with clinical medicine, either in the pediatric field or in the geriatric field, knows that when someone comes with a high natremia, is or she is supposed to be dehydrated, and there are some neurological signs going eventually to coma and confusion, and therefore we think that if large dehydration leads to coma and neurological signs, we may think that milder dehydration could be involved in cognitive performance. It's only an idea. We have no proof for that, and this is what I'm going to try to show you. The story is an old story. It started around the Second World War when military personnel had to train in very difficult environment. And we started, the military people wanted to have as few casualties as possible. So they start thinking in terms of what can we do to prevent casualties. And some studies were performed in Cambridge in the UK, and this one also was performed, trying to find whether on these military personnel that were dehydrated, voluntarily dehydrated, whether we could or not spot some arguments in favor of cognitive impairment. In this study, military personnel had to run for 6 hours on a treadmill and then stay quiet for 2 hours. And eventually, after 8 hours of this treatment, they were asked to see, to say whether they could see in their visual fields some images and some things. And what Leibovitz showed was that there was not at all a decline in the neurological function or cognitive impairment, because there was a faster response time to something that was shown to them in their visual field. So at this time, it was considered that there was no relationship between cognitive performance and dehydration. Then came the culprits, and I think there are two studies, two groups, which provided 4 studies, and they took a very strong hammer to make the point about the relationship so strongly that people still believe that it is true. On this one, and it is the same story as another one by Sharma, it's the same group. They took 11 Indian soldiers, they made them exercise at 45 degrees Celsius, 30% relative humidity, with no drinking until they were dehydrated to the extent that they lost 1, 2, 3, and 4% of their body weight. And after this weight loss, They recovered in thermoneutral environments so that their heart rate and body temperature get back to the baseline value. And they asked them some questions about making simple calculations, asking them for recalling some words and numbers or tracking things on a screen. And they showed this curve, which showed that the arithmetic ability, the possibility to add numbers on top of each other's, was declining in relationship to the degree of dehydration. This was the main conclusion from this paper, and I insist on the fact it was 11 people with very, very harsh environment. First culprit. Second culprit is French. She is French, from the military physiology department in Grenoble, and they did something that is very difficult to understand in the paper. I've read this paper many, many times. I'm still not sure that I've understood it. Nonetheless, they took 8 subjects, and in a random order, they were subjected to 5 different conditions. One is a control condition. They did nothing around these 6 hours experiment. 2 experiments were done by exercising until the point that they lost 2.8% of body mass. And two experiments were performed in the heat so that they could lose the same amount of body weight. Exercise 1, no water added. Exercise 2, water added. Dehydration in the heat, no water added. Dehydration in the heat, water added, so that there was a compensation of a body mass lost. So they did that over 2 hours. Then there was a first test called test 1 at about 30 minutes after the start of a recovery period, and another 3 hours later. And what they show is this type of information. First, if you look at fatigue, the control period C is the white one at your left, the white bar, and you see that the 4 conditions, 2 exercise, E0 and E1, and 2 dehydration, heat, H0 and H1, lead to the same sort of amount of fatigue, regardless of whether the people were rehydrated or not. And it is so it is clear half an hour after the recovery period, and it is clear also that for exercise 1 and heat 1, fatigue decreases. These are the two on the test 2. It's the number 3 and number 5 column. You see that fatigue decreases when water was added. So this is fatigue. If you look at mood, mood is grossly unchanged over the 2 tests, and regardless of the experiment. Now, if we move to cognitive function, this is the only one that was significantly different. It is percent correct answers as compared to the control, which was 85%. It was a perceptual comparison, and as you see, all the answers are correct regardless of the experimental condition. The only thing that changed is the time for giving the right answer, i.e., it is as if these persons were able to give the correct answer to the test, but it took them slightly longer to get to the proper answer. So it's, we would say, subclinically significant. And you can see that on the right-hand side, and you see that the response time, RT, is increased, maybe slightly lower after people are dehydrated. And when I say this paper is difficult to read, this is the difficulty. I can't make sense about what is significant and what is not significant. Here we see obviously that compared to the control group, it is increased, the response time, but it is not written clearly in the paper whether the hydration does improve or not the response time as compared to the dehydrated situation. And when we plot everything, all the tests that were performed, you see fatigue is increased in both situations. And any change that occurs in the dehydration heat or dehydration exercise is similar between the two conditions, leading the authors to say that dehydration either acquired in the heat or acquired through exercise lead to the same cognitive impairment. And you can see that fatigue is increased, mood is not changed, and the only thing that is changed is short-term memory and the response time for perceptual comparison. So these studies were performed, in military personnel. They are cited over and over again, and there are the basic arguments to say that there is a relationship. This was the reason why I wrote this in 2005. Since 2005, there are many more papers that have been published, which I've put on this table, which is easy to understand. The experimental stress on this table is mainly exercise plus thermal stress. And these are the four that we know. And in all of these four circumstances, we see that there is a change in cognitive performance in a yes or no answer, regardless of whether it is important or not. And since there are more publications that have been performed, one on repeated walks with slight change in cognitive performance, we'll talk this over again, one by Suzanne, which was not about cognitive performance, but about perceptions. And the others are basically on water restriction, and when there is water restriction only, there is no change in cognitive performance. Another one on exercise and water restriction with a change, and another one, last one, on exercise with water restriction with a change. So today in 2011, I have big difficulties to say that there is a relationship between this. And there are limitations into all these studies. The first limitation is that when you ask someone to exercise for 6 hours or dehydrate him over 2 hours, he's tired, and I assume that this fatigue has something to do with cognitive performance. The other difficulty is that it is also said that exercise stimulates cognitive performance, and it is difficult to say which is which when there is exercise plus thermal stress plus water restriction. Plasma glucose is differently affected by exercise and its heat stress, and probably many metabolites are in the course of an exercise, for example. And as cognitive performance is basically the work output of a neuron, we should be looking also at the metabolic environment, which is never done. There is a methodological issue about learning, because when you repeat the test, you learn how to perform. So probably if you're smart enough, your second answer is better than the first one, and you might, compensate for a small effect of dehydration if there was. Mainly these studies are on young subjects, and I can remember for myself that 20 years ago I was able to do things after a night without sleeping that I can't do now. So maybe they have a huge cognitive reserve that they can use, and which I can't use any longer. But I think that this is a big limitation, and especially in the one when I said they reach the correct answer, but slightly slower. It's always a limited number of subjects, and I really wonder what we can say about a study on 10 subjects. And if there is only water restriction, it appears to be with no effect. Now, if we look at two populations that are probably more prone to cognitive impairment, the elderly person and the child, let's see what it gives. There are very few studies performed in the elderly subject. This one is a study that has been published in 2004 and an extension in 2011. which was a comparison of 14 subjects aged 51 to 82 that either abstained from drinking overnight or did drink overnight. As you see, they are 63 years old, they are well educated, their reported thirst and reported mouth dryness is slightly increased in the, slightly decreased, for example, in the group that abstained from drinking, and the percent of total body water overweight is slightly lower in those that abstained from drinking, and the authors used this indicator as an indicator of dehydration. Total body water was measured by bioelectrical impedance. This table shows that psychomotor processing speed was influenced by age, was not influenced by systolic blood pressure, and was influenced independently from the other determinants by their hydration indicator. Memory was also influenced by that. So they concluded that hydration, as assessed by total body water divided by weight, influences these two cognitive assessments. I fear that percent total body water overweight is a very poor indicator of cellular hydration, which is the key issue in this term. They didn't mention what was their body composition in the first hand, but if you assume that by bad luck, this dehydrated or abstaining from water group had a higher fat mass in total weight, they have a lower fat-free mass, therefore a lower total body water. It could just be something else but hydration. I don't say this is all wrong, but it's not precise enough to reach a conclusion. A second study was done by the Klaas Westertub's group in Maastricht, and they asked 11 people aged, I think it's 50 to 61, 51 to 60, to walk 20 miles a day, 10 days in a row. That's an exercise in the Scottish Hills. As you can see, the urine osmolarity of the older group was higher on day 11 than in the younger group. And they had many, many metabolic measurements, and one measurement of a response time, which was a reaction time to spot errors between two figures. And they showed, these authors showed that there was a relationship between the change in urine osmolarity between day 1 and day 11 and the reaction time. And the higher the increase in osmolarity, the higher the increase in reaction time. So this is probably the best, if it's good enough, proof that we have in elderly people, slightly young people still, because they are below 60, that there is a relationship between osmolarity. Urine osmolarity is a good indicator in these circumstances, and reaction time. And the last experiment is very interesting, this one. It's a clinician that performed it. It's an anesthetist. And during bowel preparation for colonoscopy, you have to drink these naughty products that give you diarrhea for a few hours, and people get dehydrated. And these people, these 38 people that were studied, all were above 60, and they lost 2% of weight. And because it's over a short period and they had diarrhea, we can assume that this weight loss was water. And as you can see here, if you look at the zero, zero is a difference between first and second test, before and after. You can see that all these tests were unchanged, although these people certainly lost water. So if we summarize the data in the elderly, there are very weak evidences that there is a relationship between hydration and performance. In children now, there are very few data. This one is a study that was performed in South Israel, and they took Jewish children, and they separated them depending on their urine osmolarity in the morning. Above 800 milliosmol per kilogram, they considered that they were dehydrated, and below 800, they considered that they were hydrated. And you see that there are almost 40% of their children that are dehydrated. And I said Jewish because they performed the same study on Bedouin children, and apparently this high rate of dehydration or increased urine osmolarity is specific to the Jewish kid and not to the Bedouin kids, so the authors said in the paper. And when they asked them at noontime to perform some very simple test, the only test that was changed was a number span, i.e. they asked them to recall 8 numbers. They told them 8 numbers and asked them to recall the 8 numbers a small time after, so it's short memory. And it was the only indicator of performance that was different between the two groups of children that were aged 12 or so. So first study. And second study is an English study that was performed by Miss Edmonds. 2 studies, in fact, showing the same thing. This one was on children that were 8 to 9 years old, and because they considered it was unethical to dehydrate the children, they separate the children in 2 groups randomly, one that was allowed to drink over the morning and another that was not allowed to drink over the morning. So a mild difference in dehydration, and if any difference, it may also be the difference between hydrating the kids as compared to the reference, more so than dehydrating them. Nonetheless, so in this study, for which the table is shown, the children drank 212 milliliters in the group that with additional water, and they didn't drink in the other group. And again, there are very few cognitive tests that are improved during these trials, mainly on short memory. And they repeated the study on slightly younger children, age 7 to 8, drinking a little more, and they find exactly the same thing. Now, I changed the presentation because there is an EFSA, the EFSA has issued a recommendation recently about the allegation of a relationship between hydration and cognitive function. And this is a conclusion. The panel concludes that a cause and effect relationship has been established between dietary intake of water and maintenance of normal physical and cognitive function. And the panel considers that in order to obtain the claimed effect, at least 2 liters of water. So the sentence is very important. It says a cause and effect relationship between dietary intake of water and maintenance. It doesn't say that shortage of dietary water is associated with impairment of a function. It says that. And when they put the arguments, the scientific evidence for that, they quote a paper by the International Institute of Medicine in the States, dating back in 2004, which I think is a bit outdated now. So my conclusion is, in young subjects, the effect of exercise plus water restriction plus heat stress may alter mildly cognitive function. In the elderly subject, young elderly subject, there is no convincing evidence. In the children, there are some arguments for the prevention of a sort of noon decline of function in calculating or repeating numbers when they are given water in the morning. But in total, I think the evidence is very weak and more studies are required. probably targeting some frail and cognitively impaired person if we want to see something. I thank you very much.